Hello, my friends. Today's topic, solving systems of linear equations by graphing. Our essential questions: how do you solve a system of linear equations by graphing? And what does the solution of a system of linear equations mean? Let's get rolling. First off, a system of equations. This is a set of two or more equations containing two or more variables. Our point of intersection. When we graph, this is where both lines cross or intersect. This is the solution to the system. Here we have an example below. We have these two lines. These lines go with the equations over here, y equals 4/3 x plus 2 and y equals negative 1/3 x minus 3. The solution to this system is the point of intersection right where they cross. That would be -3, -2. And that would be our solution to this system. Just like we've been doing in class, if we plug this x and y into these equations, it will work out and we will see that it is indeed a solution to this system. When we graph two lines, there's three different possible numbers of solutions. One solution is when they cross at one point. No solution, that would be like parallel lines where they never cross, they never intersect. There is no solution. And infinitely many solutions, if you can't tell on your paper here, there's actually a line on top of a line here. So that's two lines right on top of each other, and these cross at an infinite number of points. They're crossing everywhere. So we say infinite number of solutions. Let's take a look at our example here. Solve for this system by graphing. As we graph these, you're going to want to remember our equation of a line, y equals mx plus b, where m is the slope and b is the y-intercept. For the first equation, the slope is the m, negative 4/3, and the y-intercept is 1, right there. Now that we know our slope and y-intercept, let's start by plotting the y-intercept. Our y-intercept is 1. So what I'm going to do is put a point right on the y-axis at 1. That's our y-intercept where it crosses the y-axis. Then we want to plot two more points using the slope of negative 4/3. This is a negative slope, so we know the line is going to go downward, and we could use those triangles that we've been working with to find the other point. So I'm going to start here and make my triangle, and I do my rise over run, and I know it's going to be negative, so I'm going to go down 1, 2, 3, 4, and then over 1, 2, 3. And that's where I'm going to put another point right there, using that down 4 over 3. And we want to plot two more points just to give us a little bit better of an idea of how to draw this line. So now, this time I'm going to go up 4 and over 3 to finish that line off. So 1, 2, 3, 4, 1, 2, 3. And I'll draw my next point right there. There we go. Now that we have three lines, we can draw a straight line right through all those points, and we've graphed our first equation. Let's move on to the second. In this equation, it looks like the slope is 1/3, and the y-intercept, that b, is a 4, but it's a -4. So we're going to put y-intercept is -4. Let's plot the y-intercept first. That's where it crosses the y-axis at -4. And then we want to plot two more points using that slope of 1/3. This is a positive slope, and we can use those triangles like we did before. So starting here, I'm going to go up 1 and over 1, 2, 3. It looks like it's going to match with this point right here. And let's go the other direction just to get an extra point. I'm going to go, instead of up 1 this time, down 1 over 1, 2, 3. that rise over run. So I'm going to get another point right there. And we could draw our line straight through those, and that gives us our line for our second equation. Now we want to identify the point of intersection and write that solution as an ordered pair. So that point of intersection where those two lines cross is right there. If we find that point, that's going to be 3, negative 3. So the solution of this system is 3, negative 3. Moving on to our second example. We're also going to be solving this system by graphing, and we're going to do those same steps. First, we want to find the slope of the first equation. That looks like it's negative 2/3. We also have our y-intercept, which looks like it's a positive 1. First, we're going to start by plotting the y-intercept. That's where it crosses the y-axis at 1. That's our y-intercept. Now let's plot 2 more points using our slope. And it looks like our slope is a negative slope, meaning it's going to be going this direction, downward from the left. And our rise is 2, our run is 3. So starting at this point, we go down 1, 2, over 1, 2, 3. That's going to be our next point right there. And then I'm going to go the other direction just to make a nice even line and get 2 points. So starting here, we know the line's going to go this way. So we'll go up 1, 2, over 1, 2, 3, and we'll get another point right there. That'll give us our first line just like that. Beautiful. Our second equation, y equals negative 2/3 x minus 3. First, our slope is negative 2/3. That's that slope right there, negative 2/3. And the y-intercept is a minus 3, or a negative 3. Let's start by plotting that y-intercept of negative 3. That's going to be right on the y-axis, right here at negative 3. Then we want to plot 2 more points using that slope, negative 2/3. This is also a negative slope, so it's going to be going this direction. And we have that 2 over 3. So I'm going to start by going down 1, 2, over 1, 2, 3. There's going to be my next point right there. And then let's get our other point by going the other direction, which is going to be up here. So up 1, 2, over 1, 2, 3. That's our next point right there. And now I have my next line. Now this is looking pretty interesting. Let's see. Is there a point of intersection? That's what we want to do next. Identify the point of intersection and write the solution as an ordered pair. Now this is an interesting one. Let's see what they're asking here. It says, the solution of the system is the point of intersection. Will these two lines ever intersect? These actually look like they're parallel. They don't look like they're going to intersect, which means this is actually no solution. Just like we saw at the top, whenever lines never cross, parallel lines, there is no point of intersection, meaning there is no solution. All right, now's your turn. Try these two problems out. Go ahead and just start with this first one for now. Remember, start with your y-intercept, then use your slope to find the next points. I want to give you a little hint here. This slope of negative 2, that's like a negative 2 over 1, and that slope of 3 is like a 3 over 1. So whenever you don't have a denominator, you can use that 1 to help know how much you're going to have to move over. Go ahead and try to graph that and find the solution now. All right, let's see how you did. Starting with this first equation, we have a y-intercept of 1. I'm going to start by drawing my point at the on the y-axis at 1. Then I have a slope of negative 2, or negative 2 over 1. So that's going to be down 1, 2 over 1. That's my second point. Then I can start back at that middle point and go up 2 over 1. That's my next point right there, giving me a nice line, whoop, right about like that. The second equation has a y-intercept of -4 or -4. So we'll start on our y-axis at -4. Using our slope of 3 over 1, that's positive, so it's going to be moving up to the right. That's up 1, 2, 3 over 1. Looks like we'll have another point right there. Now, it is nice to graph 2 more points, but we can already see that they're crossing right there. So if I draw my line, I can see that my point of intersection is right here, which is at the coordinate 1, -1. So my solution to this first one is 1, -1. Perfect. All right. If you didn't get that one, go ahead and fix that now. Then move on to this second example over here. I'm going to give you another hint. We have a negative x. That's like a negative 1 over 1x. So that negative x is like a negative 1 over 1x. We can use that to help us with our slope. Equation, x equals -4, that's actually a vertical line at -4 on the x-axis. I'm going to help you graph that second equation. So this second equation, x equals -4, I have a point on -4, and x is always going to be -4, so I actually get a line like this, a vertical line on that, I'm going to draw that a little better, on that -4 parallel to the y-axis. You try to graph this first equation and see where it crosses this one. The y-intercept is -2 and your slope is -1 over 1. Try to graph that now and see if you can come up with the solution. Starting with our y-intercept of -2, that's going to be on the y-axis at -2. Then we have our slope of -1 over 1. That's going to be a negative slope, so that's going to be moving downward. So I'm going to go -1 over 1. That's going to give me another point right here. And I could draw that line, but I'm going to try to put some more points so I can be more accurate. I'm going to go the other direction, up 1 over 1. I'd have another point right there. And if you can't tell where they're going to cross, you can actually keep doing more and more points. Up 1 over 1, up 1 over 1, up 1 over 1. And eventually, if you keep using that slope, you'll see that you should get a point where both of those lines cross. In this case, it looks like it's -4, 2. I'm going to put that as our solution, -4, 2. Take a second and write your summary for these notes. Make sure you're answering the essential question on the top in 3 to 5 sentences. All right, I hope this was helpful.